All right, here we are, question 4. So, I added this part right here. I dropped that in there of this table. We'll talk about that in just a second. Let's look at the question before we go look at this table. The value of a collectible toy is increasing exponentially. So exponentially, it means it's got the same growth rate. There's some same number that they keep multiplying by over and over and over again to give us this exponential growth. And the 2 points in the graph show the toy's initial value and its value after 3 weeks. So check it out. At 0 weeks, this thing was worth $5. It started off at $5. After 3 weeks, it was worth $10. So let's break down these coordinate points for a second. I think a lot of people are intimidated when they see a graph and they don't know what they're looking at. Every time I see a graph, and anytime you see a graph, what you want to do, look at your axes. Read what's going on here. Look down here on my horizontal axis. I got weeks since purchased. So this is 0 weeks. We got 1 week, 3 weeks, 10 weeks. Those are the weeks down there on the horizontal axis. That's your 3 right here. Your 0. X goes on the left, Y goes on the right. Technically, that's X and that's Y. And we write our coordinate pair like this. It's alphabetical order. X on the left, Y on the right. So weeks is on the left here. Now, what's my vertical axis? It's value in dollars. This thing, these are my dollar amounts that this toy is worth. So that's why I put this table in here, so we can analyze what's this coordinate pair telling me. On the left, I got weeks, 0 weeks. And you can kind of see it from the graph too, not just the coordinate pair there. And then how about the 5? The 5 in that 0, 5 coordinate pair. Here's the value. It was worth $5. 0 weeks. That's the initial, the beginning value. That's where we started. And then 3 weeks, after 3 weeks, this thing is worth $10. All right, so we know what those coordinates mean. Now, there are some people that are going to see this and immediately say, hey, you know what? This thing doubled. It just went from 5 to 10. That's times 2. But maybe you don't see that. Maybe it's some more complicated numbers where you don't know how to divide them and it doesn't make sense what the rate was. Or maybe the growth rate was some fraction or something like that. What you're going to do, take what we want to do. We want to find out what we multiplied times 5. What number did we multiply times 5 to make it equal to 10? And the way you do that, you take 10 and divide it by 5. And that'll tell you what number you can multiply times 5 to make it 10. So I'm going to write this. Here's my growth factor. 10 over 5. Well, 10 divided by 5, 5 goes into 10 2 times. So we got a growth factor. Our rate of change is 2. We're going to keep multiplying times 2 over and over and over again. But one thing to keep in mind, this happens over a 3-week period. Every 3 weeks, the value of this toy gets multiplied times 3. It's tripling every 3 weeks. The value is tripling. Next. Oh, yeah, I just wanted to throw in a quick point there. Let's say you get all mixed up and you forgot which one, if you're supposed to divide the 5 by the 10 or the 10 by the 5, and you put 5 over 10, trying to figure out your rate of change, and you get 1/2. I want you to take a look. When you come up with this number here, take a look at your graph and see which one aligns with the graph. This graph is going uphill. We're multiplying times a number greater than 1 to make the number increase. If you multiply times 1/2, it would be going down like this. So we know it's not 1/2. I just want to throw that in there because I don't want you to have to memorize, divide this by that. I want you to know how to check your answer, and if it's right, this is increasing. So that makes total sense. We're multiplying by 2. And it does not make any sense that we'd be multiplying by 1/2 because that would make it go downhill. Now let's put it all together. Let's put these pieces together here. I'm going to write this. I'm going to call this T. This toy, the value of this toy is a function of time in weeks. They told me to express the toy's value, T, in dollars as a function of time in weeks after it was purchased. So here's time. This is function notation, okay? This is just a fancy way of saying Y. T of W is 5. It's 10. It's whatever these numbers are on the vertical axis that align with your graph. If you just write Y, I'm totally fine with that, actually. I'd probably still give you full credit. But here is our function T. The value of the toy is a function of weeks. Where do we start? We start at the beginning. Every single time, start at the beginning. It doesn't make sense to start anywhere else. Why not start at the beginning? So we started, this thing was worth $5. Here's the original value. We're plugging it right into our formula. Start at the beginning. Next, we're going to multiply times that rate of change. We figured out that this thing is doubling. It's doubling each 3 weeks. Now, you might think that they're multiplying times 2/3 each week, but they're not. That is not how this works at all. You'd be totally wrong if you're thinking that we could just multiply times 2/3 each week. It would be going down in value, not going up. That doesn't work at all. 2/3 is less than 1. That would make it go downhill. That is not what we're doing. We're going to throw in an exponent that expresses the fact that each week is 1/3 of the 3 weeks that need to go by. We need this whole 3 weeks to go by for this thing to double. So if only 1/3 of that time has gone by, guess what? We still got this same doubling going on, but only 1/3 of that time has passed. So let's write our exponent. Weeks, W for weeks. W for weeks. And out of how many weeks do we need it to double? 3 weeks need to go by. And there you go. That is the answer to this one. If you just got like this part right here, you just told me where we started and the growth rate, I'd probably give you about half the points for that. But if you can figure out, here's the most important part about this exponentials. Knowing what your exponent is going to be. Did the whole 3 weeks pass? No, we're writing in this for 1 week, and it takes 3 weeks for it to triple. So we're going to say 5 where we started, times 2, our rate of change, and W out of 3, because it takes 3 weeks for this thing to double. And then you could take a look at part B. I'm going to take this out of the test. I don't want to confuse you any more than you are already. So I'm cutting this one out. But maybe it might help you to understand a little bit if we talked about it. Or you might just be interested in what's going on here. Write an expression to represent the toy's value 10 days after it was purchased. Well, we're using 10 days. And I don't really want to convert 10 days to weeks. That'd be weird. But I can convert 3 weeks to 21 days. Because we need our fraction to line up. So I'm going to convert the 3 to 21 because there's 21 days. And there's 21 days and 3 weeks. So I did 7 times 3 is 21. And only 10 days are going by. So you could put a 10 in here too. But that's how we would do that one. But like I said, I'm not going to put B on the test. I just want you to be able to find the growth rate by dividing this by that. Throwing it in right here. And then figuring out how much is going on right here in our exponent.